So I think I mentioned at the beginning of this chapter that, like, throughout history, before we even understood how the planets orbit the sun, people would look up at the nighttime sky and see these wandering objects. Okay, and so as it turns out, actually, planets do not stay a part of any particular constellation. Planets glow because the sun, just like the reason our moon shines, planets shine because light from the sun strikes them, and then that light is reflected back to us, our portion of that light, and we see that. And planets, though, appear to move against the background stars, quite frankly, because they are orbiting the sun. Okay? So the word planet actually means wanderer, and they're definitely wandering. So when I say they move against the background stars, in a given night, you're going to look up and it's going to look like throughout the night, it's going to look like it's a part of a constellation. When you come back the next night, it's going to actually appear to move, make sure I get this right, it's going to appear to move eastward, okay, night after night. I guess a fun exercise that I would have had you do is to look at the movement of planets night after night after night against a particular constellation. Okay, that's what they usually do. That's called direct motion of planets. Now, every once in a while, every once in a while, the planets, instead of going eastward, they go westward. And this is actually called apparent retrograde motion. Apparent retrograde motion. It's like a backward motion. An example here is Mars. Okay, so let's see, against the background stars, let's see if we can find direct and apparent retrograde motion. So here we have June, okay, June, July, okay, here about August, so this is direct motion. Okay, here about August, it started to go backwards, okay, or westward, and that is called indirect or retrograde. And I'll tell you, I'm going to show you why that happens. But then here, can you see in September 29th, it picks back up direct motion against the background stars, again, eastward. The reason for that is because can only be explained if the planets, the Earth and Mars, if we both orbit the sun, we can explain that apparent retrograde motion. So I have a couple of figures for you. One is a couple of people walking on a track, and maybe you already kind of figured this out, but these people actually are going to be like, that would be like E for Earth, and that would be like M for Mars. These people are kind of like planets. One of the things that Kepler found is that the closer the planet is, okay, to the sun, okay, the faster it will move in its orbit. Not only does it have a smaller orbit, but it moves faster. So here we go. Here we have this person in a blue shirt on the inner track, and she is moving faster. Now notice for positions 1, 2, and 3 that she is approaching the person in a red shirt. Okay, they're about 3, beginning actually kind of 4, and maybe even 5, she is overtaking the person. Okay, so she's going faster, and what it will appear that that person does, and I don't know how to convince you of this, maybe we just need to do a little demo, but here as the inner track person in the blue shirt overtakes the person in the red shirt, the person, from the perspective of the person in the blue shirt, that red shirt looks like it's going backwards. Then here, about position 5, 6, and 7, okay, the person in the inner track going faster has clearly overtaken that other person going slower in the outer track, and then again the person in the outer track has what we call more, has direct motion against the background. And I tell students, it's kind of like if you are driving a car, kind of similar to this. If you're driving a car and you're going faster and you're kind of catching up to somebody going slower in the other lane, if you look at that person against the background, what it's going to see is you're going to see that person kind of go one direction against the background. As you approach it, it's going to feel like it's go backwards, and then as you go past it, it goes the same direction again. It's hard to explain, but that's exactly what's happening. So, like I said, we can explain that backward motion, that retrograde motion of Mars, okay, against the background stars the same way. So here's positions 3, 4, and 5. 3, 4, and 5. Okay, the Earth is the blue planet. Okay, and then the Mars is that orange planet outside of it. Now, Earth is moving faster. They're about positions 3, 4, and 5. The Earth is overtaking Mars. Okay, and then it's actually has overtaken it, and we have direct motion 6 and 7. So, actually, this idea of observing this kind of backward motion while we pass a planet in its orbit is or was early evidence to scientists that actually the planets orbit the sun instead of something crazy like everything orbits the Earth.